going to do this in terms of activity. Let me write the reaction. All we guess. Do this. Oh, my other one's got 3 or 4 erased. One ending up on one side. And I said all these look like this. And what happens is the water is lumped into this K term, case of A. So that it's fit into the K term, and you just don't bother putting in the equilibrium expression. You use a lot of different reasons for that, but that's one of them. And concentration of water, and we did this calculation way back in 1B. About 55 or 56 molar if you have pure water, because you have 1,000 grams of water divided by the molecular weight 18 in a liter, and so the molarity of water in pure water is about 55. And it's not going to change when these concentrations are 0.02, 0.05, or whatever. Okay? So that's why we don't worry about it, and sometimes I say except water just for that reason. On this particular problem, I didn't. Oh, there was one other thing I wanted to mention about this problem. I'll put the right button this time. Alright. Oh, this thing switches it where it not. There it goes. Notice I was careful to convert everything into concentrations. Does it make any difference? No, because this has concentration squared over concentration times concentration. It's a dimensionless K. I already talked about this. This is exactly the same as the number for K sub P for that reaction. And so if I would have put moles into this particular problem, I would have gotten the same answer at the end. So I could have done this one in moles instead of molarity. But in general, what you always want to do is plug molarities in here. Most of the time, it's not going to work out that easily. But this time, it would have worked out if you had not changed the moles to molarities. That's all I wanted to point out about that. And people that, boy, somebody's really messing up my charts up there. I have to speak to some of the other instructors. Those things cost money. Not everybody cares about an X on rhodium. Okay. Okay, so coming back to this thing, that's all I wanted to say about it. It happens to be dimensionless. K sub P and K sub C are the same number. And whether you plug moles in or molarities, you calculate everything the same way. The numbers will be different as you go through it. And at the final answer, you still have to convert to molarities. Why? Because it says, what are the concentrations at equilibrium? It doesn't say how many moles at equilibrium. So eventually you do have to convert to concentrations. And the safest thing is to always work in concentrations with these problems, because that's the kind of equilibrium constant you have. Okay, now coming back to the problem. There it is. And you had number 4, right? Yep. And it says, use the chemical formulas, and you have 0.335 molar. That's the C0, or the nominal concentration. We've got this pretty much set up. Forget about what I was talking about water here. But sometimes you'll see when I write the quiz, I'll say all the species except water. And that's the reason that's why I don't really ask you to do water. And it's just I guess. So you're doing the Ka, you got this thing set up. I said all acids and bases, we ultimately end up with this problem. Ka 5.92 times 10 to the minus 5. And I said, for 99% of the problems, you are going to have the first approximation being satisfactory. And so you always solve it that way. And if it doesn't work out to be very good, you can go ahead and make a second approximation, a quadratic. That's worth an extra point to solve. So I always solve it. And starting concentration, I just read it to you a minute ago, 0.350. And X1 came out to be 0.0455. And I wrote it with 3 significant figures. I said I like to see that. And so the first thing you want to worry about, is my approximation any good? And usually if we're within 5%, and occasionally you'll see some weird oddball problem. I haven't come across one of those in this textbook. But sometimes the author will say something to give the answer with an accuracy of better than 1%. If you just look at this, we ignored this x, which is about this number. So you have this sort of thing. Oh, my eraser isn't in the right place this time. 455. So you can see it's 4 parts in 350. It's a little over 1%, but it's well under the 5% that this textbook usually goes for. So the first approximation is satisfactory. Okay. So now the next question is, you want to start answering, or the next thing is you want to answer these. It says use the correct chemical formulas. This is where you have to worry about conjugate acids and bases. This is the acid. What's the conjugate base? I wrote A minus up there. It's a C4 O2 minus. That's the conjugate acid base pair. So what you can say is hydrogen ion is equal to, I just wrote it there, C4H7 O2 minus, and it's all equal to 4.55 times 10 to the minus 3 molar. Concentration of the acid itself. And now we just do that subtraction there, and it's going to be about 0.03 47. In other words, I just took C0 minus X1, close enough. And then the whole thing about all species, and that's the thing I keep trying to remind you, this is an aqueous solution. We have hydrogen ions, we have hydroxides. This is the one you calculate from KW. And by the way, if you just put KW and you get the right answer, I'll assume you knew what KW was and you did it right. If you get the wrong answer, I'll assume you didn't know what KW was, and I'll take an extra point off, because I said that was the one K you should know. Okay. And if you remember, when I was talking about this and I wrote this equation, and I wrote the ICE, I put this as C0, and I said this was approximately 0 because we were ignoring the water. This is the amount of hydrogen ion that came from the water that we were ignoring in this step. Any other questions about that? No? Yes?
When you're checking for your percent error, I know this isn't part of the problem, but it's, when I was doing the online homework, they sit to make sure your value is within a 5% error.
Right.
So you're checking that with your X value, right?
Right. If this
as long
is
as your X value, the difference is less than 5%.
In other words, this is how much we ignored, so it was under 5% of this original value. If it would have been over 5% or even 4%, then I think the book that problem set would have wanted you to do the second approximation.
Okay.
In other words, it means that it should be within 5%, and let's say this number came out to be 0.045. If K would have been like, well, let me do one. Let me just change that K. And do the same problem with a different K, just to show you what happens. Instead of this K, I'm going to use -2. Okay. Now you go through this and you say equals approximation x squared over 0.350 minus x. You can still certainly do the approximation, right? So you ignore this thing. I already said approximate. That doesn't look like it says identical. But that meant I already ignored the x. So I go through this. And I get 0.143. You can see right away, this is 1 part or 14 parts of 35, that's about 20% error. Okay, so that approximation wouldn't be very good at all. So that's all you're doing there, you're just making a rough approximation or looking at the thing you ignored compared to the thing you were saying you could ignore. If it's an appreciable part of that, in other words, now we're comparing, and it's 14 parts in 35, or about, 40 parts in 100, that's about a 42% error. So now we either have to go through the second approximation, for my purposes, as long as you recognize that that's not a good answer, and you show me one of the ways, best way for this one, since these two numbers are very close together, you probably would have to do about 3 or 4 approximations till you got to the right answer, and you're better off at that point going into the quadratic formula, unless you didn't remember the quadratic formula or you didn't have it programmed into your calculator. Yes?
How did you get 0.0347 polarity?
I subtracted. This C0 minus X. Oh, that's why you don't want to take shortcuts. There it is. In other words, until you do a bunch of these, you know, the whole reason I said is you always want to set these up with all the different ICE tables. After you've done about 20 or 30, you say, oh, there's a shortcut I can take. But you have to do 20 or 30 to be able to see the shortcuts and have it make sense. I expect you to do 20 or 30. I already did 20 or 30. Okay? Yes?
I think it is 0.347.
0.347? Did I subtract wrong? Let me subtract. Oh, that's what she was asking about.